Okay. We'll give it a minute after, so that to give sufficient people time to join. Welcome, everybody. Welcome to the seminar on recent laser safety incidents at the DOE complex. We'll just give it a couple more minutes before we begin. I see people just joining in. So I think we will go ahead, and I'm just going to kick off this seminar. Everybody, welcome to the 2026 Multi-Lab Safety Week. This is one of our first seminars this week. It's on recent laser safety incidents at the DOE complex. And we're going to have Jamie King from Livermore, laser safety officer at Livermore, give this presentation. Aaron Potash, Division Safety Coordinator for ATAP, is going to introduce Jamie King. Aaron, could you please join the podium? And Jamie, could you also join the podium? Go ahead.
So very happy to introduce Jamie King, who's a mentor of mine and trained me at Livermore in laser safety. So Jamie King, he's a certified laser safety officer with over 30 years of experience practicing laser safety. He has served as the laser safety officer for NASA Ames Research Center, Sandia National Labs in California, and is currently the laser non-ionizing radiation safety officer lead for Lawrence Livermore National Laboratories. Jamie is a member of the Laser Institute Board of Trustees. He represents LLNL on the ANSI Z136 committee and serves on the ADCOM, the SSC1, SSC8, and TSC4 subcommittees. He has authored numerous papers and articles, including the DOE Laser Lessons newsletter with worldwide distribution. He has served as the general chair for the 2023 and 2025 International Laser Safety Conferences. Jamie was the 2019 recipient of the R. James Rockwell Jr. Educational Achievement Award for his contributions in laser safety and was selected as a LIA Fellow in 2023.
Thank you so much for the great introduction. Jamie, I'm going to stop screen share, and then if you can share your screen, and start the presentation, that would be great. I appreciate you joining us and preparing for this talk.
All right. Thank you, and thank you to Aaron for that great introduction. So can you hear me?
Yeah, now, thank you. Yeah.
All right. So I presented a couple years ago on this this topic, and it's recent laser incidents and lessons learned at DOE Labs in 2024. We added a little spin to it. This time I'm adding, but I don't have enough lines on the title to how we onboard new laser workers at the laboratory. So this is very important to us, reporting off normal events. And we've been doing this, as you can see, it goes all the way back to 2000. So around 2003 to 2005, we had a lot of off-normal events which resulted in permanent injuries. And that caused the DOE to issue a special operations report. And so at that point, we did a whole lot of changes. One of those was we started a laser safety officer workshop. And this presentation was originally given. We hosted it here about May 19th to the 21st of this year. We typically pull in over 150. We had about 165 people here at Livermore. And so we go through the years, right? And we want to be able to understand what's happening and then try to correct those things and learn from those things. So as you can see, the orange is actual injuries. We haven't had an injury for a while, but we've had an elevated, accelerating off-normal events. And it's pretty subjective because I put out a request for these every 2 years before our workshop and ask the different laboratories to report on their off-normal events. So you get what you get. And so I'm going to take this information for what it is, and we'll talk about some of those. We actually had 28 off-normal events since the last workshop, which was held back in May of 24. And you can see we report back into March and April. Some of these weren't reported until after we got back from our workshop. Highlighting here, I just brought up a couple of different themes. A lot of them I'm going to report subcontractor things. So this one, a subcontractor brought inadequate eyewear for work. Worker accidentally turns on a laser with no eye protection. Worker reached across the table, not wearing eye protection. Worker was using a laser scriber with just regular safety glasses on. And so out of these 28, I'm actually going to cover 6 of those in depth. While performing an interlock check, a worker was found not wearing correct eye protection. An incoherent filtered eyewear was found in a laser lab. And what that means is, so your laser eyewear manufacturers, some of them sell laser protective eyewear. And there's also, because LEDs are real big and all these bright lights, they also sell incoherent light eyewear. And in this case, this person had procured their own eyewear outside of the system, and it was found that it didn't have the proper optical density ratings and wavelength on the glasses. And then we finish off with a subcontractor, again, brought in inadequate protection for scheduled work. And this is happening more and more often with the subcontractors who come into work, right? Their job is they come out here to maybe repair a laser, do some maintenance or something on it. And their management basically is just telling them, hey, we got a job at Livermore, go get this job done and move over to your next job. And sometimes they don't know the finer details of the safety side. So we visit every single subcontractor that comes out, inspect, basically have a conversation with them, look at their stuff. And if their eyewear is inadequate, we'll provide them. We don't want to send them away because they're going to come back again, and we don't want to pay for another visit, but we want to make sure they're safe while they're here. So I'm going to go through six incidents or off-normal events that had happened at different laboratories. I'm more familiar with the ones that happened at Livermore, and so most of these will be at Livermore. So this first one involved a class 4 laser. It's a 2-watt laser, 1550 nanometers. And if you understand the spectrum, the 1550 is not hazardous to your retina. It's absorbed in the cornea. So you can absorb a much higher output laser than you would with the retinal hazard ones. So this worker brought in this laser, looks just like what you see here in this image, but the laser was not authorized to be used under their current work control document. And the way that we lay the work control documents out at Livermore is a catch-all in the work control document states that one of the binding conditions is that you cannot operate any laser that's not on your attached laser inventory table. So this was not on their inventory. a pretty good class 4 laser. They brought it in. Now their work control did cover closed loop laser work, which was class 1. So that means that the fiber optics that come out of here were connected to a detector, and there was no way anyone could be exposed. So, right, we have one failure mode here, which should not cause anyone to have any problems with getting exposed. But the worker was not getting a proper signal. So what did they do? They decided to troubleshoot. And there's troubleshooting was not included on this work control document. So it was only closed loop class 1 work. So they start troubleshooting, trying to figure out why they're not getting the signal. And so they had to disconnect one of the fiber ends. Boom, now we've got another failure mode, and that failure right there would expose them to class 4 laser radiation. So they disconnected the fiber end, and at some point, somebody noticed that there was a plastic dust cap that usually you put on these fiber ends, and that they're just what they're called, dust caps. So the plastic cap was put on the end of the fiber, and somebody noticed that it was totally burned off on the end. Work was not paused nor stopped, and the incident was not reported until sometime later. So, right, class 4 open beam operations were not authorized, and this laser was not authorized. So, right, you've got to go through one failure mode should never get you exposed to something. And so one of the weird things that happened in this situation I'll cover is the input that came from the worker. So what went wrong here, right? Our contributing factors. So the laser was not authorized. The troubleshooting and scope creep, which always happens with these things, introduced a hazard class 4 beyond what was approved in the class 1 operations. And the worker thought that the cap burn was no big deal, and this was their input because the fiber was directed at the floor. So they had hung the fiber down towards the ground, and the ground was concrete. And so they said, well, what's the big deal? There was no potential to expose anyone, which was kind of a flies in the face of being safe. They did not pause or stop work. They just didn't think, right? The worker didn't think it was a big deal because it was pointed at the floor. So it's like, hey, let's just continue. No foul, no harm. And the plastic dust cap was used as a barrier. So what you see over here on the right side, I think it was the Nevada test site, I think put this together. These were all different kinds of dust caps. And what they did is they used lower output lasers and figured out what to measure the transmittance through these, because people will stick a cap on the end of a fiber and think that, well, the laser light's blocked. But as you can see, some of these were, almost 50% transmissive that the laser light was coming through here. And in this case, it was class 4, so it just burned right through the cap. You need to use proper caps, and in this case would be a metal cap that you would put on the end of the fiber. So, right, big lesson here is fiber optic dust caps are not laser barriers. So, right here we had several layers of failures, and fortunately no one was not hurt. And that was because the fiber was actually pointed at the floor. Now, that's what we were told, but we know no one was injured in there. I didn't see any burns anywhere else. So, that one fortunately turned out pretty good. So at Sandia National Labs in 2024, this was in August. So the worker was adjusting the repetition rate of a laser using their graphical user interface. And this is getting to be a real scary thing in not only lasers, but probably other types of equipment, where the graphical user interface is becoming very, very user-friendly and kind of skirting on the safety side of the house. So the software malfunctioned and caused the laser to switch over from pulse to continuous wave mode. And when that happened, the high-power continuous wave beam reflected off of a neutral density filter, which you see here in this top image. So it reflected off the neutral density filter, hit the curtain inside the room, and burned a hole right through the curtain. So the result in damage to the density filter was ruined. It burned a hole in the safety curtain surrounding the table. So you want to be aware of and block stray reflections in the beam path. So one of my primary goals when I set up safety, in my world, laser safety, is I try to confine the laser beam to the optical table, so that if something like this was to happen, I would hit a barrier guard on the edge of the table rather than, go out and hit the curtain. If I'm hitting a barrier, it's usually made out of aluminum or something. It's going to burn that. I'm not going to burn right through it where I could easily burn through a curtain. So what went wrong here? So the beam path, like I mentioned, was not contained to the laser table. And this image right here is after, they did it after action items. And so here you can see these barrier panels. They need to be higher than the optics on the table so that if something gets misaligned, it'll strike this metal. And then you're relying on your curtain. And if I have a burn on the table right here, it's not a big deal, right? If I'm burning a hole through a curtain, that's sort of a big deal because I'm burning and I could transmit a beam into an uncontrolled area. And with these higher and higher powered lasers, the kilowatt, tens of kilowatts, and higher class lasers, you can actually start burning through walls into other rooms. So you really want to maintain that you've got control of your laser beam on your table. So this graphical user interface was out of date. The manufacturer knew it, but failed to inform the purchaser, Sandia. Now, we had a problem like this happen several years ago here at Livermore, where we had a kilowatt class laser, and the graphical user interface came up on the computer. It looked very user intuitive, but it had two on buttons. One button was like about an inch away from the other button. One was to turn on the alignment laser, and the other was to turn it into this other mode, which they accidentally pressed that button and almost blew a hole through their finger, which was about an inch from the beam where they put in a viewing card. We took that laser out of service, contacted the manufacturer. They had no fix for it, and so we just didn't use that laser any longer because it was very unsafe. The other thing is user manual is not available. So lasers like to float around, right? If you've got a laser at your facility, someone may want to use it. You want to make sure that the manuals are available and a transfer with the laser itself, because you want to make sure that whoever's using the laser understands all the functionalities of it and all the safety of that laser system. One of the requirements is if you do send a laser to somebody else, transfer a laser, that manual has to go with that laser. A little bit later in the year, Sandia had another incident. A worker was training to operate on a new laser system, and they reached across this table right here, and to adjust an optic, and was exposed to a class 3B laser through upward directed beam splitter while not wearing any eyewear at all. The polarizing beam splitter that was on the table allowed the laser beam to leave the horizontal plane of the optical table. And so one of the most important things when you're dealing with an optical table, right, they can get very, very complex. You can have optics all over the place. One of the first things I do when I go in and I'm working with a brand new user or a brand new laser system is, in a nice way, hey, what are you doing? Explain to me what kind of science are you trying to get out of this? And then can you explain to me what's going on with the laser beam? And that forces them to kind of walk through the optical path of their laser. And you never want to have a user come in and not understand the optical path and then turn the laser on. Especially with the housekeeping on some of the optical tables, you might end up having something put inside of the beam path. So in this case, what went wrong here? And I'm trying to locate that optic on the table. I think it's right here. And so what went wrong is there's a beam splitter right here on this polarizer. And so the previous user of the system noticed that there was a bright spot on the optical table. So the beam was coming through, and part of the beam was being reflected down onto the table right here from a 740 nanometer laser beam. Now, in talking in lasers, 400 to about 700 is the visible portion of the spectrum. Some people can see out beyond 700 to even a low 800 nanometers. But if you do, it's kind of like looking at an iceberg. You're only seeing the tip. So you're seeing like a couple percent of the beam where the rest of it's invisible. So this 740 nanometer spot on the table, concerned this user. So what did they do? They put a piece of tape. You can see that white tape on there on the bottom of the splitter to stop it from going onto the table. Well, that tape there acted as a reflector, and it allowed some of that light that was reflected down to reflect back up out of the splitter, and that's what hit the user. A hazard analysis was not performed for this system, and the big takeaway here is to communicate any changes or potential issues with a beam path configuration. Right, anytime, and you're going to see this as we go into a couple more of these, right? One thing for the safety people to really take into account is there's never really a simple change. And that'll point out from this one that I'm going to talk about here. So this happened at Livermore, May of 2025, where we had already a setup laser operation going on. They had set up a new laser in here, which was all approved. And so what happened is we had laser workers in here who had an approved laser system, but we needed to bring in timing folks. And the timing folks' job was to come in here, and there was a shutter on the table, and their job was to set the timing on the shutter so that it wouldn't clip the laser beams. Laser one was a 12 milliwatt output, 655 nanometer, pretty low output laser, in the visible. And then we had a regen, which was 1064 nanometers, 300 hertz rep rate, and putting out 4 millijoules. That laser was being trapped on the other side of this wall back here, and lower output was coming through. Now, the workers came in to do this work, and they had their own work control document, and they were going to use the laser's work control document so that they did not have to create an entire work control document. So, the laser workers came in here, they turned the laser on, they got everything going for these people, and they made an assumption that, well, these people who are the timing folks understand all the laser hazards, which they didn't. So they came in and they set, you can see where the arrow's pointing, they set an oscilloscope down on the floor right here. So what they needed to do was look at this oscilloscope for a signal and then look and see when the shutter closes. So you can already see a problem here. So they were standing here and they were looking at the shutter, and then they had to look down at the oscilloscope. So the workers are required to observe both of these. So they keep, going up, going down, looking back and forth. It's supposed to be a quick job. You always hear that one. Hey, it's just a quick job. Well, it didn't turn out to be very quick. Took a while. So what happened? There's 2 step stools that were in this lab space, and they walked over and grabbed those step stools, brought them over to this area over here. The laser workers saw them take it over and didn't say anything. Now, when they sat at these step stools right here, it put their face right at beam level where the laser beam's inside this enclosure. Now, they understood, that they were supposed to stay outside of this enclosure right here and just look in. But they showed me how they were going, standing up, sitting down, standing up, sitting down, looking over the day, that by the end of the day, a worker was complaining of eye pain. So, right, the takeaway here is conduct a full job review, no matter how small the task may seem. In this case, we didn't feel that we needed to go in and do a full task, to update this. Maybe we should have created a work permit as an addendum to the laser work that was already being done here. But there was big misses. So what went wrong? So the laser work and the timing work was authorized under 2 separate work control documents. And this is a good image showing the worker here looking at the oscilloscope and then looking up here. So the job was understood to just be quick, in and out. The worker seating brought them in the plane of the laser beam. And so you can see everything. When they had to stand up, they would kind of lean forward and stand up. So we didn't know how far in that they were getting, but we did know that we did the calculation that there was no way they could have been overexposed by what was going on in the enclosure. Now, the reason they complained about their eyes hurting is that the glasses that they were wearing are pretty nice glasses, but when you fit somebody for laser eyewear, you generally don't fit them when they're wearing a clean room mask. So that clean room mask lifted their glasses off their face a little bit and caused a gap at the brow. And they were spending their whole time kind of looking over their eyewear through the top of their glasses. The oscilloscope was located lower than the beam path. So in this case, right, if we would have done a check on this, never assume, right, never believe anything when somebody tells you it's a quick job. What should have been done here is maybe we lifted that oscilloscope up here, put it on a stand, or actually we could have closed this door and put a camera on that shutter, and they wouldn't even have been exposed to anything. They could have just looked at the camera to see the position of the shutter. So asking enough what ifs would have probably prevented this from happening. But the point is that you quickly go to well, this is a quick job. So, it's, and a lot of people will complain, the workers, well, geez, it takes me longer to get the safety part of this approved than to get the actual work done. And in this case, it took almost a full day to get this job done. And we got in a situation where we spent a lot more time doing reviews of what happened. up at Lawrence Berkeley. So this happened in October of 2025. And if anyone, I think anybody who's online right now has probably seen one of these, has seen a request for one of these. These are all over the place. So this is an X-Tools F1 Ultra laser mill. It was found to be misclassified as a Class 1 laser. The F1 actually comes in 2 versions, and you don't know that unless you go into their operator's manual on their website and search for it. The model MXF K002-B20 is a Class 4 laser, which this version is. And the MXF K002-001 is Class 1. And the Class 1 version is typically sold in Europe. Not a lot of people request it in the US, but there's interlocks and such that need to be used to make this thing Class 1. And this one happened to be a Class 4 laser. So when you're buying one of these, when you're buying any kind of laser cutter, engraver, any of these things, you need to request a Class 1. And so one of the biggest hazards with these beyond the laser light is the industrial hygiene hazard of whatever you're engraving or cutting is coming out of this. So I've added industrial hygiene onto these things so they can figure out anything that this person's going to stick inside there, because most of these just come out, go through a HEPA filter, and then evacuate into the room. And you're finding that admin staff, anybody's trying to buy these now. And I will say laser cutters and engravers are the new laser pointers, right? When laser pointers first came out, they were going everywhere. They're very hard to find any that are less than 5 milliwatts. And it's very hard now to find any of these cutters and engravers that are actually Class 1 systems. This is a very interesting one that just happened earlier this year at Livermore, involving a laser laboratory that had been basically taken over by another group. So a worker was conducting laser work in an established laser lab. The worker placed a beam block in the beam path and left the lab space for a short period of time. And there was no rhyme or reason why they put the beam block in place. They weren't putting in there for any safety reason or whatever. They just happened to stick a beam block in the beam path. So they left the laboratory. The safety interlock system was on and was activated. So they were operating remote, right? They weren't in the space, but the laser was on. But the safety interlock system said, hey, laser's on, authorized personnel only in the room. And the crafts personnel needed to perform preventive maintenance on a roll-up door to the space, and they went over and opened up this door. And this is a picture that the user of the lab came back. They returned to the lab and noticed that the room was very bright. So they looked across the room and they see, what is that? And you can see there's it's hard to see through there. There's actually clean room plastic that's inside the room. So when you're in the room and this door is never opened up, basically people didn't even realize there was a door there. So the crafts preventive maintenance is to roll the door all the way up, roll the door all the way down. And it took a little bit of time to get this done. The laser remained operating in this entire time. And I can tell you that this is facing west. And if a laser beam had left this laboratory space, it's in the direct path all the way to SFO Airport. And it is a Class 4 laser, which would be dangerous all the way over there. So one non-interlock door, one lock, one key, all held by one employee who made one assumption, created all these multiple points of failure here. So what went wrong here, right? Contributing factors. So I'm showing you the room here, which is now used as something else. This room, if you know, we built a laser called Happels. It's a petawatt class 10 hertz system. We built it for the Czech Republic. And when we built this laser system, we were contracted to do this. We decided to build it optical table by optical table. So what happened when the laser was completed and we needed to ship it out to the Czech Republic, we flew it out on a C-130 out of San Francisco, and we took the tables apart and shipped table by table. Now, to do that, we had to cut a hole in the wall of the building and put that roll-up door in it. When the actual, they had to roll it out through the door. When the roll-up door and this was all left, I said, hey, we need to add interlock switches to that roll-up door. And this was kind of an over-budget system. I was told, no, we're not going to use this room for anything else. We're going to ship this laser out of here, and then our team's getting out of the room. So they decided that they were going to control via an administrative lock rather than safety interlock control. And that interlock, the administrative lock, fell under the control of the facility manager. Now, the facility manager came in and assumed that the laser operations were not active because there's an operations board in the building, and they saw that the responsible individual was not at work that day. The alternate responsible individual was, and they didn't verify that. So basically the facilities folks came over, said, hey, we need to do preventive maintenance. The facility managers looked at the status board, didn't bother walking down the hall to look at the laser status of the room, and the door was open for about 15 minutes. So a worker who had previously been unaware of the door noticed it was open, right? This worker walks in and they're in shock because it's like, why am I seeing this bright? So the first thought in their mind is, I need to get some pictures of this because I don't know what's going on here. They didn't hit an e-stop or de-energize the laser. So fortunately, that beam block was in place. It was holding that laser beam on the table. But I will say this time and time again, relied upon for too long, every single administrative control will fail at some point in their use, always. I have never had, the longer we've had administrative controls fail in as short as a week, and we've had them, go years and years, and then all of a sudden they fail. In this case, everyone forgot about that door being controlled by one lock. So, those are the main ones that I wanted to point out. Miscellaneous items. So, these are the big ones that always happen. Laser pointers labeled as class 3R, but they're actually at 3B or 4 levels. Really, are there any legitimate pointers out there anymore? We confiscate laser pointers all the time, and they're typically the green ones, which are lowest, are putting out about 50 to 70 milliwatts. And then you'll see these things sold on Amazon, on eBay, where it says, hey, play with your cat with this laser. Oh, and also you can burn through plastic with it. Well, if you can burn through plastic with the laser, it's not 3R. So they're skirting the rules by claiming that they're class 3R. For a while there, you could get the really, really high output stuff, and that's kind of gone away. But they're still out there. Visual fault locators, right? These things are used to check fiber optics. So we have long runs. All the labs have long runs of fiber optics in different places. There's been improperly labeled ones found at more than one site where they're claiming they're class 1, and there could be 3B or 4. Some of them are labeled correctly, but beware of these things. The only saving grace on the fault finders is they have very short focal lengths on these because they connect to a fiber optic. So if you're holding it, any distance from you, you shouldn't have a problem. But the ones you're buying on Amazon that coming from the Far East, they're pretty dangerous. Eyewear, vendors are arriving with no eyewear, or eyewear that's they're found not wearing eyewear, or they're found with inadequate or not usable eyewear. We've had people come to our lab where we ask to see their eyewear, and they'll open up their bag and it's stored with all their tools, and they are scratched and cracked and just beyond use. And you talk to the users and they just don't understand the hazards of it, right? They're told to come out, do a job. And so we leave them hopefully with some information that, you really need to protect your eyes. And then incorrect eyewear found in use or in laser controlled areas. That's still being found in different places. It's a difficult thing, especially when you have a community bin. During COVID, we got away from that, but we're starting to go back to a little bit of the community eyewear, just because a lot of the eyewear is so expensive to get. Laser cutters, engravers, like the one I mentioned, right? Enclosures are being found not to be interlocked or not to be light tight. They're non-certified, and unauthorized laser engravers are found in operation. This one, I think, was sent by Greta up there at Lawrence Berkeley. These are just, like I said, they're the new laser pointers. They're everywhere. Everyone's buying them. I'm signing requisitions for these. I spend more time trying to approve these things than I do with high-powered lasers. But I just don't know how many are sneaking through the system, right? Because there's so many ways to buy things, and these are becoming so inexpensive. We spent, I approved one. It was about $15,000. So I figured, okay, it looked good. It had metal panels and everything on it. When it got here, our folks went through it, had an an undersized power supply, all kinds of electrical safety concerns. The panels would come off. We ended up putting, I think, another $15,000 to make that engraver safe. So buying cheap, does two things. One, it gives you might end up with something that's not certified, not safe. And the other is you end up running a lot of the legitimate companies out of business because you're buying all this stuff, and then all you're going to be left with is this non-certified, unsafe things. So what does that take us to, right? So we had 28 different incidents that happened since over the 2 years since the last workshop. But you got to look at the laser use across the whole complex. So, quick look at this chart. Livermore has a whole lot of lasers. Sandia's got a lot of them too. Los Alamos and then Argonne are like the 4 biggest users, but the rest of them, they're contributing. There's a lot of laser use that is going on. So we have approximately 10,000 high-powered lasers across the DOE complex. One of the reasons we put this workshop on, and so one of our biggest attendees now is no longer the Department of Energy, it's academia. A lot of universities are coming to our workshop, and so the good thing is that we're trying to instill the kind of safe applications that we do that they're importing, and so and I'll talk about that when I get to the training part, but they're incorporating our training also. So what is the state of laser safety across the complex, right? So we've got about 2,000 laser controlled areas, about 10,000 class 3B and 4 lasers, and that's from the laboratories that are reporting to me. So that's a lot of laser use. So since the last workshop in 24, so that was updated. So we got 28 off normal events. And the majority of this work is in an R&D environment, right? That's the situations where something can really go wrong. So we've had a lot of near misses and off normal events. So we've got a lot of work to be done. But in comparison to the amount of laser work that we do, there's really a small amount of events that are happening. So the takeaway I always tell people with this, right? Near misses are always the result of not paying attention to the details. And accidents are the result of not paying attention to the near misses. You want to pay attention to the details so you don't have these near misses and you don't have these accidents. So I added a little add-on to this about, I was asked by Smita how about onboarding our new laser workers at the laboratory, right? So we've got a trifecta of courses that we offer. And the first one is our laser worker online training, which is about 2 hours. It covers laser fundamentals, hazards controls, PPE regulations, and our laser safety program at the lab. It's required for all 3B, 4, and embedded class 1, and we repeat this every 3 years. Now, this is what we refer to as the Department of Energy Laser Worker Training. So a bunch of us got together several years ago working with NTC, the Department of Energy National Training Center, and we created this laser worker course, and we've just updated it in the last year and a half, something like that. So it's a very, very good course. Most of the laboratories use it, and we also offer it for academia. So universities can contact me. I'll put them in contact with NTC, and they provide them with the files so that they can put it in their own wrapping and provide that training to their folks. Some of the stuff's not applicable to academia, but the basics part of it are. So that's the first thing that happens when somebody gets to our site. They have to take that training. Then we have an in-person course, which is called Laser Safety Conduct of Operations. It's kind of a lessons learned, and most of the laboratories have this. So it covers lessons learned scenarios. It's required for all 3B and 4 and embedded class 1. It's about an hour, and right now it's a one-time only, and I'm thinking about bringing back the 3 years. We got rid of it years ago because incidents weren't happening. We didn't have anything really to talk about, but there's a lot of stuff we can talk about these days. And this is more of we get together, we break out into teams, and we go through a couple scenarios. Each team has a different scenario, and they have to figure out the contributing factors and everything that happened in an incident. And then one of the team members has to be the presenter and presents it to the rest of the group. And we find that trying to hold this class to about 12 to 20 people in 2 groups, it works out pretty good. We try to make sure everyone participates. And they really get a lot out of this, trying to, them coming forward and saying, well, I think this is what went wrong. This is what went wrong. And a lot of this is human behavior stuff and things that, you just wouldn't think. And then the last thing is we have a laser alignment training course. And this is a hands-on course. It's about 4 hours. And it's an in-person course that covers laser alignment methods and safe practices. It's required for anyone who will perform an alignment task involving class 3B and 4 lasers. This came about Los Alamos after their incident they had in 2005. They created a course. SLAC took that course. We visited SLAC and then incorporated their course. And then Lawrence Berkeley created their own course. So reciprocity is granted for the laser worker training because we're all taking the same course. And then a laser alignment training. So LANL, Lawrence Berkeley, and SLAC, we provide reciprocity if somebody has that course. It really helps speed up when we have visiting scientists going back and forth. And so with that, we go to our alignment course. So we had to upgrade our alignment course because we had an incident that involved a user was performing a task where they claimed they didn't understand an optic, and it involved a beam splitting polarizer, which is notorious for causing eye injuries. So the NIF Photon Science Directorate held a management review. That's where it happened. And out of that management review, they said that our training program was inadequate and needed to be updated. So we've changed the course now to a learn, practice, and test. So this laser user alignment and reference guide, and I'll throw props out to Lawrence Berkeley. We basically took a reference guide that they have, and we've incorporated, so if you want to look at your camera, so we incorporated in this spiral bound, and I'm willing to provide this to anybody who wants to get a copy of it, but it's about 130 pages, and this thing is meant to last a user basically their career. It has a lot of good information in it. They get that, and then they get assigned to a mentor. That mentor will then provide them with their hands-on practical where they use low-powered beams, they set up, they manipulate the laser beams under guidance. Then the one other part that was put out that says we had an inaccurate course was we didn't have a testing. We kind of had a subjective, hey, you looks like you're doing it good enough, go ahead and you pass. Now we actually have a test where if the student's ready, and we provide this test if somebody is a long-time user and they feel like they can just bypass this other part, they can go right to the test, take the test. So this is a picture of our room. We had a very small, it was an embarrassment of a room. It was in a closet. Anybody who came to Livermore, that was the first thing they saw was they came and trained in his closet. So we've got basically a very nice room now. We were given about $60,000. We bought all kinds of equipment, an optical table, Vidmar, all the tools that you need. We took over a conference room. We've got a TV monitor. We can put up videos. So in the room, generally we won't have any more than 3 students. We like to just have 2 with the mentor in there. We also use it our fitting room. You can see all the glasses over here on the wall. So we fit people for laser glasses. We have a full-fledged interlock system inside the room so they get trained on that. And then there's a barrier with a sign and everything when you come in. So the whole thing is set up like, with the exception of having a carpeted floor, it's just like a laser laboratory. And some of the things that we train them on, this is another fault of our previous training, is the gland tops and polarizer, periscopes, flip mirrors, and dichroic mirrors, right? These are the optical components involved in most laser accidents. And so we go over them with the student so that they can understand that these are things that you need to be aware of. The first one here, the beam splitting polarizer, is notorious, especially in tie sapphire lasers where a lot of times people are mentored wrong and they're not wearing laser glasses and they turn this thing and you can see a little output port on here. And when they turn this thing, they get a beam up in the eye. It's just notorious for people. So the course doesn't make them an expert, but it can raise safety awareness, introduce the best practices. So when they first come in the room, you want to make sure, hey, they're removing reflection hazards, right? Their wedding ring, if they have rings on, if they have a watch on, their badge, they understand where the beam's located. They've got good beam control alignment techniques. They're communicating with others in the work and the other workers, and they're familiar with the PPE that's in the operation. And so in this case right here, this is the testing criteria where before we just had them complete a certain, basically you had a chart and it says, hey, you need to complete scenarios 1, 2, and 3. In this case, they have a test and they're scored by excellent, good, poor. They have to score a minimum of 10 from here, from all of these 1, 2, 3, 4, 5 different things. And if they do that, then they get scored off on completion and they complete their training. So the other thing I wanted to bring up is our newsletter's back. So for years, since 2012, I've been writing a newsletter that goes out internationally, all the DOE labs, academia. And right around COVID, I basically shelved this thing because we didn't have the resources to do it. So with the help of my rest of my office, especially Carla Armstrong, we've introduced the newsletter. We've put 2 issues out this year already. We have the 3rd issue in draft, which is a cover of basically a recap of the laser safety officer workshop. And so this thing goes out. We've got all of the issues online. So if you want to get on the distribution, send myself or Carla an email, and we'll get you on that distribution list, and you could get access to all the back issues. This is a very good resource. A lot of people are using it for their ongoing training. We cover, basic laser safety things like, this is the components of the eye, and maybe a lessons learned or near miss that happened in the last quarter. So really good that that's out. And with that, that's all I have. Thank you.
So thank you so much, Jamie. You can stop screen share and then let's stay online. We have a few questions in chat that I was going to read. This was a really great talk. You explained all the issues and the incidents really well. The first question, is there a counterfeit or a knockoff laser identification program or link similar to what UL has for items that they have identified?
No, it's one of the biggest pet peeves that we have in our laser world is that, so any laser that's certified for sale in the US has to get FDA certification. Now what happens is it's a self-certifying system where the manufacturer sends a package to FDA, and they're issued what's called an accession number. And this accession number basically just says, yes, you've self-certified. Well, what we're finding is that some of these counterfeit lasers are posting accession numbers on them that aren't even real. And when you call the FDA for the accession number, they won't give it to you. They treat it like it's privileged information. So it's very difficult. It's like you don't have a one-stop shop. We've even had legitimate laser sellers. I won't name the company, but I was turned on to this by one of our users where they have a spectroscopy, and they, for some reason, I guess they wanted to find out what the materials of a vinyl record were. So they brought in an old vinyl record and they hit it with this laser, and it burned a hole through the record. Well, if it burns a hole through the record, it's not eye safe anymore. So we contacted the vendor and went over months and months, and this was certified outside the country, but it was never came to our satisfaction. But going back to that question, it's very difficult to determine what is counterfeit and what is not in today's world. And I'll tell you that a lot of these websites look very legitimate. They put all of the stuff in there. It's just like any other thing. If you look at the label and something just doesn't look right, it's probably not right. They try to copy as best they can, but we're trying, we've been trying for a very long time to try to figure out, are these counterfeit lasers? Are they misclassified lasers? What are they? Because it's not a laser trying to say that it's, if it's a bolt or something, it's not trying to say that it's some other company's bolt or whatever. It's just a laser that's claiming that it says it's class 4. Yes, it's class 4. Is it certified? They claim it is. And then when you get it and you dig through it, you find out it's not. So it's the wild, wild west.
It's a wild, wild west. Yeah. We did have an incident here at Berkeley Lab where a speaker from another national lab was using a laser pointer, and that ended up being the output was a class 3B laser. I'm sure you heard about that.
And they're everywhere. It's really hard to find a legitimate laser pointer. But what happened when COVID, there was legitimate companies out there, and when COVID hit, a lot of these companies went out of business. And now you're left with it's hard to find a company that, because what happens is you might have bought from a distributor and you had a nice, safe laser pointer. You go back to that distributor and they're just buying from some other company in China. And so now now you're getting a different laser in the same kind of packaging.
Yeah. So the other question is, what eyewear do you recommend for short pulses, 100 femtoseconds to 1 picosecond lasers, wavelength 1030, 515, and 257.5 nanometers?
So I would say if you can use glass. Glass doesn't have the same problems as polycarbonate. If you're going to use polycarbonate eyewear, I would recommend that you look at NOIR, N-O-I-R. It's NOIR is there. We'll look them up. They actually do third-party testing on their ultra short pulse lasers, so you know that you're getting tested eyewear. Josh Hadler out of the National Institute of Standards and Testing did a study on this years ago and found out that most of the eyewear being sold did not meet ultra short pulse requirements. One of the problems was that in order to get the glasses, he had to sign documentation basically stating that he couldn't divulge whose didn't meet. So he left it up to everybody else. But I will say that the NOIR, they use third-party testing out of Europe. And so they actually come with the certification that say it is. And mineral glasses also doesn't have the problems with polycarbonate. So go with that or go with a third-party tested. Don't just take the rating that a company might tell you. If they don't have the certification, then the only other thing you can do is test them yourself. And most people don't have that capability.
Can a user cross-reference the FDA number? Also, does the FDA have the only jurisdiction over these, or do other international organizations have standards and regulations?
So the IEC, it's under 60825 is the rest of the world international. And that they'll certify lasers through that. And there's an agreement where if a laser is sold internationally and it's IEC certified, that it complies with FDA. I like the IEC stuff better. It seems more legitimate. The cross reference, like I said, you cannot. I have never been able to access accession numbers, so I don't. If you call FDA and ask for an accession, say the laser has an accession number on it, and you just want to verify it with FDA, they just won't provide you with that information. I don't know if it's lack of staffing but we've been told before that it's kind of proprietary information. It's the same thing with IEC where they do, I think it's TUV, does independent testing. With the laser, we were trying to find out whether it was class 1 or not. We ended up running into a roadblock at the very end because they sent us a document that was all blacked out, and they said everything on there was proprietary information, which was the information we were looking for. So it's difficult.
Difficult. Okay. So any other questions? Those were the ones in the chat. I see that our division director has joined. Cameron, would you like to say a few words? You can turn on your camera. I think there's, if you just see a dark screen. Yeah, there you go.
Yes, thank you. I just want to add my thanks to Jamie for being with us today and for this seminar. Some great lessons. I apologize that I did have to come in partway through and wasn't here to welcome you. We do have a program manager visit today as well, but great to hear from you and very much appreciated.
All right, and I will try to get our folks who are, with their laser-based accelerators to join up on this maybe the next time you do this. And yeah, we'd be happy. We do this every couple of years. So in 2 years, we'll have new lessons learned and all those things that we could report on again.
Okay, that would be great. And also, I'll definitely send you an email about getting the newsletter. That seemed a very interesting resource to have. So
yeah.
All right. Yeah, thank you so much. We are just about done. We appreciate this. It was very useful, and thank you for preparing for the presentation. So
all right, thank you.
Thanks very much.
Thank you. Bye-bye. Bye.